Hello, everyone. Thank you for joining us for another live webinar hosted by EETech and Control.com. My name is Dale Wilson. I'm the VP of Engineering and Content for EETech, and I'll be your moderator today. Our session, Weathering the Challenge of Long-Range Data Communications, is brought to you by Omron. Our presenters are Kerry Horan and Bob Cresson. Kerry attended the Georgia Institute of Technology, where he obtained his Bachelor of Science degree in Mechanical Engineering. He is currently the Business Development Manager at Omron, serving as America's technical contact for Omron's diverse sensor product offerings. He has expertise in the manufacturing field, including IoT, smart cities, and agricultural applications. Bob co-founded KS Technologies in 2003 and currently serves as its president and CEO. For over 12 years, Bob was a hardware design engineer at Hewlett-Packard and Agilent Technologies, where he created integrated circuits and designed system-level test and measurement instrumentation. He has bachelor's and master's degrees in electrical engineering and has been awarded 2 patents. After the presentation, I'll be leading a panel discussion with the presenters, followed by a live Q&A session with the audience. You can submit your question at any time during the webinar using the Q&A section at the right-hand side of your screen. During this presentation, there will be several poll questions, so keep an eye out for those, as we'd really like to understand your thoughts in these areas. And near the end of today's presentation, the slides and a flyer about weather sensors will be available for download from the handout section on the right-hand side of your screen. And we do hope you'll stay to the very end and fill out a brief survey to help Omron better understand your needs. And with that, I'd like to hand things off to Kerry to begin the presentation.
Thank you so much, Dale, and thank you everybody else for joining our presentation today. As Dale said, we're talking about weathering the challenge of long-range data communications, and this is a joint collaborative effort between Omron and KST to bring our weather sensor out to the new age in communication and IoT. So just if you are familiar with some of our webinars in the past, you may have seen our weather station be talked about in previous webinars, and we're excited to introduce this new form of communication with KS Technologies. If you're not familiar with us, we'd like to give a little bit of a background of who we are. At Omron, we are a corporation that is composed of several different entities that is international and based in Japan. We cover a couple of different business divisions: our industrial and automation systems for pick and place robotics, light curtains and safety. Our social systems and solution services that cover a lot of public works, ticketing for trains, for train stations in Japan, Our medical division, which covers blood pressure monitors and medical equipment that many of you may be familiar with. And where we come from is our device and module solutions. Previously, that was utilized primarily with component level applications such as relays, connectors, switches, and sensors. But recently, we have been getting into more complete module solutions, such as the weather station that we'll be talking about today. And to get us introduced to Bob and KS Technologies, I'd like to show off, if we could, put up a little video of Bob showing off our weather station that we're talking about today, as well as a little introduction about himself. So if we could play that video, please.
Have you ever wondered what the weather was like at some remote location? Well, now you can with the new Omron weather station and the KST wireless IoT gateway. This thing is completely robust, no moving parts, measures temperature, humidity, wind speed, absolute pressure, and even has a rain gauge for measuring rain at the droplet level, and wireless communication, either LoRaWAN, Cat-M1, or NB-IoT. Stay tuned to learn more about these amazing devices. You know what? I think it might be raining out here. Time to go inside.
All right, Bob, and we'll pass it off to you to talk a little bit more about KST.
Awesome. Thanks, Kerry. Thanks for that introduction. Bob, myself, I guess, strange. Anyway, good to meet you all. Thank you for taking the time to join our webinar today. It was really pouring out there, too, when I shot that video. But a little bit about KST. So as Dale mentioned at the start of the webinar, we are a 20-plus-year-old company located in Colorado Springs, which is about 1 hour south of Denver. Whenever I meet someone for the first time, what I love to say is just kind of our overall vision and mission as a company. What we love to do, and I believe what we're really good at, is to sense anything that might be remote. Today, we're talking about weather data, but we have expertise in all kinds of different areas. We love to gather that data, and then we love to uplink that data to the cloud in whatever way makes sense for the application and our end customers. Today, we'll be specifically talking about LoRa and how that applies. Once the data gets to the cloud, we love to make sense out of that data. It's one thing to measure data, but then to interpret it and then to apply it really brings meaningful value to that data and allows the data to tell a story. And we love to tell that data's story to the benefit of people's lives and the businesses that they run. KST really has three major business segments. The first are IoT-related products. And these are products where we own the intellectual property and you buy them and you deploy them in your environment. We've actually found over time that a niche for us and something that I believe is really our core expertise is to semi-customize those products on behalf of our customers. We maintain IP, but then our customers get a semi-custom version of that product that solves their particular problem. We also offer engineering services. Some people would call that full stack IoT, where we do sensor level development at the hardware level, but we'll also get involved with firmware, mobile applications, cloud engineering, mechanical engineering, UI, UX engineering, and so on. So we offer both products and services in the IoT space. An up and coming revenue stream for us has been manufacturing. We've always built our own products internally, but now we're starting to manage full lifecycle products on behalf of our customers. So here on site at KST, we actually have pick and place and surface mount and reflow capabilities. And we actually do all of our flash, test, box build, labeling, inventorying, and shipping all from KST. We do that for ourselves as well as on behalf of our customers. All of our engineering is done here in Colorado Springs. All of our manufacturing is stateside. We can scale with local vendors here in Colorado, and we also have a key partner in Texas. And I'd really like to end on that point. Partnerships are a key way that KST has grown over time. We have formal design relationships, design partner relationship with Nordic Semiconductor, ST Micro, and Texas Instruments. We're part of the LoRa Alliance as well as the Bluetooth Special Interest Group. And this is where the relationship and the partnership with Omron has been very special for us. We love partnering with people who have deep dive expertise in an area, bring our own expertise to the table, and create something really fantastic. And I'm proud that we've been able to work with Omron on integrating their weather station with LoRa and with the cloud. So speaking of partnerships, I'll go ahead and turn the presentation back over to Kerry, and he will take you through the partnership that exists between our companies. Thanks, Kerry.
Yeah, thank you, Bob. And as Bob said, we are happy to work as a partnership with KST, and that is really where this webinar comes from and where we're showcasing this information today. So how this really came to be, Omron's weather sensor was originally designed, and we'll talk a little bit about the history of that design, to work on several different communication platforms. And one of the main ones that we had heard a lot of information about and a lot of need about is LoRa, long-range communication applications. In our hunt for looking for ways that we can better implement technology, we found KS Technologies, who, as Bob very much demonstrated, they clearly have their expertise on working with sensors within that LoRa space. We learned about several of their other projects. So we found it was a natural pairing to get the two of us together to get our weather sensor up to the next level. So collaboration between the two groups, as I said, a natural decision to build on our product. So that brings us over into our first poll question. We know you've come here because you have some interest in looking at the weather sensor and looking at its abilities to work within long-range communication efforts. But I'd like to know, what industry are you primarily working with for climate sensing applications? Are you looking at agriculture or precision farming, smart city, smart lighting, utilities, and public works applications, general climate studies or meteorology, or if there are any other applications that you are working with? We are very eager to hear more about it and learn about what you're working on and how we can really help. So we do have the poll questions going on live right now. Please make sure to answer those so we get a little bit more information about what you would like and how we can help. So we have, of course, many different applications that are going to be utilizing climate studies for their own individual purposes. I want to talk about a couple of specific industries that we have been focused on at Omron, where we have learned a lot of where those needs arise and what some of those pain points are. Those being smart city, power and energy, and agriculture. Of course, if there are other applications, we'd love to hear more about it. But this is in learning a little bit more about where the trends are going and why this is necessary for us to have this weather station that is well equipped to work within the LoRa space. So first, we'll talk about smart city and street lighting. So we've been speaking with a number of different users that are in this space and have learned a lot about how weather sensors and climate data can work well within urban environments, especially as we're looking at a whole mesh of different sensing applications around different climates within a metropolitan area. We have seen sensors equipped over a large network to track spot weather data to share with citizens. And larger cities especially are needed to track this weather data, especially as it's covering such a wide area and a wide number of number of climates. We've seen this a lot, especially in West Coast cities. I know in the city of Los Angeles, I believe there are 5 different climate designated biomes that they're measuring, but they still need to get all of the weather data for all of these different environments quickly and clearly to citizens so that they know what's coming up in the future with weather patterns. Sensors are often equipped to high-tech street lighting, smart lighting, offering an existing power source. So by having these weather sensors in these existing spaces, high up, away from any sort of interference, we're seeing a lot of use for the sensor able to gather key data for users themselves. This data can be linked to emergency services, utility companies, and waste management for remote services. One of the big applications that we've seen recently is using these weather sensors in waste management, especially in water treatment. It's very important to measure how the humidity is, how the temperature is, and even wind patterns that might be affecting how the water is being treated and what needs to take place in order to make sure that the water is being handled safely and cleanly. Next, we'll talk about agriculture and precision farming. So we've seen a lot of need for this sort of application with sensing devices to monitor key spot data with crops and with especially over a large area. Of course, farmers are getting key weather data from websites and getting from satellites that are nearby that are tracking weather data, but sometimes it's not enough, and you need to have the spot weather data of the specific area within your field, how much water it's getting from rainfall, how much light it's getting in a given day, what the temperatures and what the humidity is. And for some specialized crops, wind speed and wind direction can really affect the health of the crops. So certain crops, especially in the citrus area, are very sensitive to these conditions, humidity, light, and temperature, and needing a climate solution, a climate sensing solution that is able to get that key weather data is very important. But the big thing with these sorts of applications is how remote the weather sensor is when it is installed. So that's where the long range communication can really come in handy. One of our big things that we were thinking about when we were looking to work with KS Technologies and to incorporate LoRa communication is how often farmers are going to be positioning these weather sensors far away, not only from potential communication towers, but also far away from where people are normally going to be checking on. There's not always going to be someone present into a field. So as long as we can have weather data that is coming immediately to a dashboard that a farmer is able to analyze, and also being able to track the weather data within that specific field is going to prove highly advantageous for precision farming applications. And lastly, in energy management, we've seen a lot of push getting into green energy, solar energy, and it's become much more prevalent as an alternative means of power. What's very common with some of these applications and with precision agriculture is where these solar farms are often positioned as in isolated areas and damage can be difficult to track. We've seen applications where they're looking for weather sensors that can provide spot conditions to indicate any need for attention, for maintenance, if a storm has taken place, or if while conditions are good, they're not getting the proper light they need to have to generate the amount of power that is required for that specific usages over time. So having the weather sensor that is able to track that spot data is going to be very useful for making sure that power is managed correctly. Federal implementation plans regulations are also calling for an increased scrutiny on energy uses. So having a weather sensor that is able to get that spot data clearly and able to properly, again, maintain how that power is being used and how that power is being consumed and what power is being gathered is definitely going to be a need for solar farming applications. So from here, we move into our next poll question as we start talking about the weather sensor itself. What is your primary concern with using weather stations for your applications? Are you coming into this looking for some long-range communication, making sure that your devices can work in remote areas? Is cost your main hurdle? You have a light financial plan and need a sensor that can work within a budget? Are you looking for something simple that is able to set up easily and does not need constant maintenance? Or are you looking for something that can handle rugged atmospheric conditions? You need a sensor that can handle extreme temperatures and weather. Of course, if there are more things, we'd love to hear more concerns, or you're looking at more than one of these that you need some assistance on. We're happy to talk with you a little bit further after this webinar and answer a few more of your questions. So let's talk a little bit about the weather sensor itself, the main product of what you came here to see and what Bob had showcased earlier with his introduction video. So Omron had been developing an on-platform IoT gateway solution for data-driven markets. The product on the left side of the slide that you're seeing is what our original product was, which was an IoT gateway module that was able to hook in with several different sensors so that users would be able to get all of that sensing data into one chipset to be communicated onto a dashboard or wherever central database that they're looking for. As we started built on this IoT gateway and looking at all the sensors, we thought more about what sort of applications are going to be needing these sensing devices. And one of the natural thoughts we had was a full climate sensing device with this weather sensor. We developed this module that would include the communication chipset in the base, as well as all of the different sensing functionalities that are needed for general climate sensing data. So the webinar will focus on the current development plan of our weather sensor, as well as the modules that are utilizing some of the technology, including our module that we're working on with KST for hooking up the sensor into LoRa spaces. So this right here is we have our weather sensor. It includes all of the different sensing functions that are necessary for basic climate data gathering solutions, all in a singular housing. We have our LPWA wireless technology. We have designed this as we design many of our projects to be low power consumption, and our design has been done to focus on a low maintenance sensing solution. So the key advantages with this product come in a couple of different ways. We have a product that's very easy to install, it being just a singular sensing station that is able to be hooked up, mounted, and have all of the different sensing functionalities. No need for a hookup, no need for a weather vane attachment, no need for an anemometer. All of those sensing functions are in that singular housing. That's rainfall, wind speed, wind direction, temperature, humidity, and light level. Number two, we have a product that's easy to maintain without all of these moving parts, without all of the weather vanes, the tip bucket for rainfall, the anemometer for wind speed. We have a product that's not going to have much risk of being locked up from any sort of dust buildup or any other wear and tear that might affect movement. The rainfall detection is done with optical sensing, and the wind speed and wind direction is gathered through ultrasonic sensors that you see right in the middle of the sensor there in that larger gap in the middle of the station, in the middle of the sensing body. And finally, low operating costs. We have designed our product to have low power consumption, and especially with the addition of KST's LoRa module, we will have a very low operating cost in how we communicate that data to the user. So to go over a little bit more specifically the sensing features, again, we have our ambient temperature sensor, our humidity sensor, ambient light sensor, wind speed and wind velocity, wind direction and wind velocity. Again, that is in that central area that we have our icons indicating to. Absolute pressure and a rainfall sensor right in the top there. So in the previous slide, you may have seen that black box at the top of the sensor. That is actually a channel where the rainfall is coming through and emptying out in that top shelf. So the rain is actually being sensed by the optical sensors that are behind those black plexiglass walls through that channel. So we come to our third poll question. What is your current relationship with LoRa communication? Of course, we are emphasizing our LoRa communication capabilities on this webinar, but we'd like to know what your familiarity with is and your need is with LoRa communication. I do not have any experience with LoRa, but I've been curious to incorporate it in my projects. I need LoRa communication for my project, but I'm having trouble finding a network to connect with. I do not have a need for LoRa communication at this time, or you need a LoRa-enabled device ASAP. If that's the one, we have some good news for you. I would say a little while ago, Omron was more on the second option where we needed LoRa communication, but we're having trouble finding someone to connect with. And that's where we find our savior and Bob at KST to help us get into that LoRa space. So this is a good time for us to pass over to Bob to learn a little bit more about the components that he had helped us out with to incorporate with the weather station. So Bob, take it away.
Thank you so much, Kerry. Great introduction, by the way, to the weather station. So let's start off with what Kerry talked about very briefly about the weather station. So there's actually two key products here that we're discussing. There's the Omron weather station itself and all of its amazing capabilities, and then what KST is bringing to the table, which is a LoRaWAN module. So in this block diagram on the right, our module is depicted with our part number, which is the KST 5421 US 915. That's a mouthful, so I'm going to call it our module instead. When you purchase both of these devices, all you'll have to do is provide a 6-volt to 24-volt DC power source to our module. The module is then responsible for providing power to Omron's weather station, as well as for getting data back and forth between the two of them. So pictured here on the left is the Omron weather station, pole mounted with a pole mount kit, and then a second device, which is our KST 5421, also pole mounted. We provide power and get data from the weather sensor using a 1-meter cable that is connected directly to our enclosure. So then your responsibility is to plug it to a power supply, and we'll show you some of those options here in a moment. The weather sensor actually uses RS-232 data to communicate to the KST module. We decode that data, and then we packetize it, and then we uplink it over LoRa. What I really love about that is it opens up lots of possibilities down the road for different forms of communication as it evolves. So today we're talking about LoRa, and we're talking about communicating with a local gateway or to a public LoRaWAN network server. In the future, this discussion might be like a non-terrestrial network for super remote applications where you don't even want to stand up a gateway. But that's a brief overview of how the Omron weather station and the KST module work hand in hand. So what else do you need in order to get data to a dashboard? How does data get to that dashboard? And what else would we need to bring to the table? At a very high level, what we like to tell all of our customers is that there's 5 key portions of any LoRa or really any low power wide area network solution. So I'm going to briefly discuss those. Let me give you examples of how we've built that out with Omron. And we even have a live dashboard today running Omron sensor and pushing data to the cloud. So let's talk about these at a high level. From left to right, the first thing that you need is always the sensor, or what we would generically call the end node. That end node needs to be equipped with a LoRa radio in this particular example, but really any end node, be it cellular, Bluetooth low energy, Matter, any of the other protocols that are out there are going to have a wireless radio of some kind in order to uplink that data or get it to the cloud. Second, generically, you need what's called a gateway. A gateway is a device that has an RF front end on it that receives those radio signals and then simply digitizes it. In the case of LoRa, the gateway is able to digitize the data, the raw data, but it doesn't yet know what it is. It's encrypted, and it's simply going to forward that data or uplink it upstream. So northbound to the gateway, in a general sense, we like to call that third component a provisioning server. The job of the provisioning server is to make sure that the end node has permission to communicate with that particular network. In LoRa, there's two particular parts of the provisioning that are really critical. One is called the join server, and the other one is called the network server. Oftentimes, I'll refer to those as the LNS or the LoRaWAN network server combined. Oftentimes, they're on the same server platform. If you're using a cellular application, it's kind of interesting. A major carrier might bring the gateway to the table in the form of a tower, and their provisioning server is going to make sure that your SIM is commissioned to their network and that you have permission to uplink data. So again, whether we're talking LoRa or whether we're talking cellular, the provisioning server is another component that's required. Northbound from there, the provisioning server typically then passes that data onto your application server. The job of the application server is to grab and ingest that data, to store it, to process it, to maybe run an AI model against it, to send out notifications or do whatever else it needs to do in the background to handle and synthesize your data. North of that is the application, which is where we as people finally get a chance to see this amazing data and to experience the end of that data journey. And that's how we interact with the data. So those are the 5 building blocks that are generically needed. Carrie has taken us through the weather station today as part of the edge node. I've described our LoRa module, which receives data from the weather station currently at a 60-second resolution or a 60-second rate. So every 60 seconds, we get data over RS-232, we packetize it, and then we broadcast that or uplink it to a LoRaWAN gateway. So that's the end node. KST does sell LoRaWAN gateways, but this weather station combined with the KST module is LoRaWAN 1.0.3 compliant, meaning if you have any LoRa compliant gateway, you can make use of this weather station. You don't need KST's gateway as long as you have a gateway in the vicinity in order to receive that RF data. So ours or any gateway is completely acceptable. From a provisioning server standpoint, KST has a relationship with the Things Industries. They're a global company that provides a LoRaWAN network server solution that is cloud-based. And so whether we're deploying in the United States or Mexico, Canada, Asia, or Europe, we have found that the Things Industries does have a platform level solution that we purchase, and that allows us to provision devices in the field such that they can communicate with the Things Industries. Again, there are numerous companies, and we'll go over some of those in the Q&A, that you could employ as a cloud-based or even a local, which is kind of interesting, LoRaWAN network server. You can buy gateways where the LNS is actually located inside the gateway itself and can do the packet decoding for you. So once that data has been decoded and decrypted, it has to go to an application server. AWS is arguably one of the world's largest platforms for receiving and ingesting data. If you go to KST's live dashboard, we're actually using AWS IoT Core to grab that data. It's kind of an upper level version of MQTT, if you're familiar with that transport protocol. We grab that data, and then we ingest that data into a time series database, which is what we're doing at the application server level. And then finally, to interact with that data, KST has built iOS and Android apps in the past that interact with the application server and allow you to view that data or set your own notification thresholds. And we also have Grafana, and our live dashboard is based on Lisand. And so that's the workflow or the data journey of how data gets from an edge device all the way to the application. Today, we're talking just about the edge node, but just bear in mind that all these layers are needed in order for you to eventually get to a dashboard. During the Q&A, we can talk about how different solutions exist for creating that data journey. Now, in terms of power, and I'll hold up a few devices just to give you an idea of what we're talking about from a size standpoint. So this is Omron's weather station. Our KST 5421 is comparable in size, and we do have just 2 connections to it. One is for power, and one is for the weather station itself, where the data is communicated over RS-232. From a power perspective, we designed the power range to be compatible with solar. So if you do have a really remote or agricultural application, you don't have a great consistent source of power, we will be offering a power solar-based solution that you'll be able to purchase. But you may have experience with that as well, in which case you can simply provide your power output directly to the KST 5421. A second option for you is to have a power supply At the moment, we are testing a rugged outdoor power supply that just uses line power, so 120 volt AC here in the United States. And it converts that data into, or that power into a power source that is compatible with our KST5421 module. You simply plug it in, and the module turns on, powers the weather station boots up, begins sending data every 60 seconds over RS-232. Take that data, we'll use the term here, we LoRaWANify it, and then we uplink it to our gateway. So those are some of the power solutions that we have in mind for the gateway, but off the shelf, pretty accessible and pretty flexible power solutions. So with that brief introduction to the module, I'm going to go ahead and turn it over to Kerry, and he will show you a few demos of this data and this weather station live and in action. So Kerry, I'll turn it back over to you.
Yeah, so we have a little demo to share, if we could put that up. Right, so what we have here is a look at our weather station dashboard from Omron, where we have our temperature and humidity, our rainfall sensing. We have our wind speed sensing, which does wind speed as well as gust. Our wind direction, which you can see that graph goes from 0 to 360. Our barometric pressure and our illuminance over a period of time. We can, of course, take that data and go to a single day and look at the time range, get a closer look at everything, take a good look at each of that key data, go spot by spot. We can zoom in pretty far in and also get this data exported to a CSV file. But I also want to show we have a live look at our KST dashboard. That is coming from KST's site, where we can do very similar things, look at all the same data, zoom in to key bits that we want to focus on. But this is available on Bob's website at KST. Actually, Bob, if you would like to share that website as we go into the Q&A. But we do have the weather station dashboard that is utilizing the data that's coming from our weather station, as well as the module through KST after it is IoTified, I believe is what you said, Bob.
LoRaWANified. I made up a word, Kerry.
LoRaWANified.
Yeah, we'll share that link. If you just go to kstechnologies.com and go under product, you can follow the path to it. What's really fun about that data is that there is a timescale button on there, and so you can mess around with it and look at the resolution. That timescale will allow you to go back many, many days. I think this has been running on my deck where it rained in that intro video for well over a week. So it's pretty cool to hit the 1 week time view button and then look at how humidity and light level and temperature change in Colorado Springs. And it also gives you a sense of the resolution involved in the weather station that Omron has created. So being able to see wind direction with 10th of degree resolution is outstanding. Maximum instantaneous rainfall over a previous minute. You'll actually see on that website all the raw data that we're getting. That is with the KST module, and that is going to a LoRaWAN gateway at my house. And then that gateway uses the Things Industries for LoRaWAN network server. We're using Lasant and AWS here to display the data. So that gives you a little feeling for what the live demo actually looked like. Thanks for letting me indulge on that description a little bit, Kerry. It's all back to you.
Yeah, absolutely. So as we wrap things up, we're coming into our vision of what our goals are at Omron and then jointly with KST. What we are looking to do with not only our weather sensor, but all of the different products that we develop, some of these more directly related, others not. But our goal is to utilize all these components to help fight off the effects of climate change and help deal with some of the effects in a smarter way. So we see a lot of the effects that are taking place across the US and across the world, where we are seeing heat waves and droughts that are especially affecting agriculture spaces, but as well as smart city, energy, and any other climate study spaces. With our weather sensor, we are able to use spot weather data in many areas to help predict and prepare for changes in weather. And it will be a useful tool in protecting ourselves and our goods from adverse weather conditions. So we hope that with our weather sensor and now with our extended communication abilities, we're able to meet your needs as well as do some help for the greater good into society. So thank you all very much. Again, my name is Kerry Horan. We are also joined by Bob Cresson at Omron and at KST. If you want any information, please, I do encourage you to reach out to us or visit our websites to learn a little bit more information, and we'll pass things right off back to Dale.
All right. Well, thank you, Carrie and Bob, for that excellent presentation and demo. I was really fascinated by the large number of respondents. That first question, who selected other for their application. So while Carrie, Bob, and I go through some panel discussion, I would encourage audience members to use that Q&A tab on the right to submit your questions, or use it to just tell us what those other applications are. I think we'd all like to see that. So let's kick off the panel discussion with our first question. And the question is, what cost advantages does LoRa offer compared to cellular or Wi-Fi communication for these weather station type deployments, especially in the rural and agricultural areas that you talked about?
I would say the main advantage really comes from specific applications where you are transferring just a lower amount of data. What LoRa really does well is be able to transfer long distance data in those small packet sizes. So where you're getting the same sort of abilities with the LoRa and the cellular, where cellular is able to have that much wider reach. With LoRa, you're still able to get a long-range communication, but with smaller packet sizes being able to be communicated over much further distances than in larger packet size applications, you can have a much more cost-effective and lower power consumption way of transmitting that data that's, you need a little bit more than you can't really have that direct power connection. You can't really use Wi-Fi, but having that longer range without having to go through a whole cellular network offers a little bit of a cost advantage in those specific applications.
That's great.
I would tend to agree, Carrie. I'd also encourage people to think a little bit about capital expenditures versus operating expenditures. So the difference between those, like CapEx, is if you're buying a LoRaWAN gateway, standing it up yourself, there's a certain cost associated with that. But once you have the infrastructure, or once you're paying a company to provide that infrastructure for you, then LoRa, if with small packets, as Carrie mentioned, and with infrequent updates, LoRa can be a far less expensive solution. So to just throw out some numbers, we've done some calculations, and when you're uplinking about 32 bytes of data, you're doing it about every 5 minutes, and you're doing it 24 hours a day, 7 days a week. We found that LoRa operationally is around 4 to 5x less expensive than cellular. Now, as you start increasing that rate, or as you start increasing your data rate, they become quite comparable. So I think Carrie nailed it. As long as you're keeping the uplink interval short and the amount of data small that you're uplinking, LoRa can be cost competitive, if not quite a bit less expensive than like a SIM card data plan that you have to have for every single weather station. So those are some of the trade-offs that are involved.
Yeah,
great question.
Yeah, and I think I'm going to pull in one of the audience questions here because it kind of plays off one of the comments I think that Carrie said was talking about power, and that plays into that operation and maintenance costs there. So they're asking, what is the power used by the end node, and are there any sleep modes to save energy?
Yeah, that's a great question. I'll start, Carrie, and let me know if you want to jump in and take it away. The ABS max power specification for the KST module and the Omron weather station is about 2.5 watts. Now, you might say, that's a ton of power, but the sleep modes really come into play nicely there. So the average power over time is tens, if not hundreds of milliwatts, which does make it a solar type of solution. So the power mode question is a really good one. So when the LoRa radio uplinks and it does its job, it waits 5 seconds for any received packets to come back, and then it goes to sleep again, and it waits for more data over RS-232, grabs that data, repacketizes it, and the process repeats itself all over again. The KST module does support downlinking, so we can send downlinks to the module to say, I only want data every 15 minutes. I want data as fast as humanly possible right now because there's an interesting weather event happening. And so that is tunable, but by default, we uplink every 60 seconds and then power save mode in between that. Carrie, is there anything that you want to add to that answer?
No, I think you covered it really well on that.
Yeah, great question.
Yeah.
Yeah, kind of to expand on some of that discussion, how does the operational and maintenance costs of these LoRa-enabled stations compare to the stations that would use those other communication protocols?
I mean, I suppose we had talked about that earlier with the previous question, but yeah, the LoRa does offer those the operational cost would be much less lower with the smaller packet size applications. And yeah, I would say that there are yeah, as Bob had said earlier, the capital investments are a little bit more of the cost increase for versus LoRa applications.
Yeah, and I would say it's a great question, Dale. I would say if you start off in like the simplest, least expensive model and then kind of work our way up, that's kind of an interesting thought experiment to have. And so probably the least expensive deployment would be an Omron weather station, a KST module, and a LoRaWAN gateway that runs the LoRaWAN network server locally. So let's say that you have an agricultural application. We've done these kinds of applications where there's a farmhouse. And the farmhouse can have a LoRaWAN gateway on the inside and an antenna on the roof. And it uses either Ethernet, which we're already paying for internet service to the farmhouse, or Wi-Fi. It can be connected via Wi-Fi. So you're already paying that infrastructure cost for internet. If you do something like that and you have one weather station and one gateway, it is literally only the CapEx cost of bringing those and standing those up. There's no recurring fee. There's no licensing fee. There's no annual subscription. Just to stand that up, you're good to go. Now let's imagine that you add 10 weather stations to your field, but they're all within range of that one gateway. The beauty of that is you're not now paying 10 recurring revenue streams worth of cost on those 10 gateways. The single LoRaWAN gateway is more than sufficient to handle the data traffic for those 10. So now you can scale to 10, but you've not really added any more operating expenses to your monthly budget, which is really nice. Now let's say that you are in more of a dense area where you have cellular coverage. If you have one weather station, it's uplinking directly to the cloud, you don't need the gateway, which is fantastic. You don't need to engage with a public LoRaWAN network server company, which is great. Your carrier is taking care of all that for you. But when you add a second device, now you've added more expense immediately. So the scaling is completely different. So it's not a really easy question, to be honest. It's really situationally dependent. And so it depends on the business and how they want to scale from a CapEx and an OpEx standpoint. But I would say they're two very different business models is how I would think about that. And we'd love to engage with people and help people understand kind of where are the trade-offs in terms of scale. But I would say the single farmhouse backed gateway is the simplest and lowest expensive option. And the 10,000 in the field using Cat-M1 is a completely different type of model. But that's how I would probably approach that, Dale. I don't know if you want to follow up or ask any follow-up questions on that. Good question.
Yeah, no, I think that's good on the cost and infrastructure and thinking about all those hidden costs that may be there, particularly for other implementations. So let's move over to kind of a category talking about range and installation and performance. So first off, are there any limitations of LoRa network availability in different geographic regions, and how can those challenges be mitigated? And I think that kind of relates, some of that anyway, would relate to one of the audience questions is, what is the range? How far can you move these things out?
Yeah, yeah, a great question that we obviously get a lot of when it comes to this. When it comes to gathering data, we're always looking for like how far can we transfer it? How far can we go with it? I will say that, there are some limitations with LoRa availability, and that's primarily because of how it is relatively new versus other traditional communication methods. The main limitation is really where things have been developed. Personally, we've seen a lot of development out on the West Coast. A lot out of course, the tech hubs of Silicon Valley, even Salt Lake, where we're seeing a lot of rise in some of the LoRa spaces that are being built up there. I've seen, I think, one group that talking around the Rockies area, Colorado and going into Arizona. But that is a growing space. And some of those are more national networks, but there's also, a use of more private networks that can be put together. And that is, it's consistently growing over time, the LoRa availability. And as far as range goes, ideal conditions, you can see data in small packet sizes. You can see data reach out, 10 or so miles. That does, of course, it can be affected by some of the geographical limitations. I think in mountainous areas, and Bob, you can speak to this perhaps as well, Bob being out of Colorado, you might have a little bit more trouble finding that signal. But in other areas with a lot of open space, a lot less interference, you can get pretty significant range of 10-ish miles on some of these applications.
Yeah, that's a solid answer. There's probably a few things to mention there. I'd say public LoRaWAN network servers and gateways are harder to find in the United States than in other countries. And so if you look at the Netherlands or France, I think you'll see amazing LoRaWAN coverage. If you look at coverage in the United States, there are public networks, but they're very geographically dependent. And so just to throw out a couple of names, so actually the Things Network is a freely available service. You do have data rate limits, but if you're near a gateway, you can just use that service literally for free. So KST, for instance, has a public The Things Network gateway. It's actually right behind me, about 10 feet away. And so if you're within 2 to 3 miles of KST, you get free coverage. You can just use our gateway. And so there is a free network there. There's also a paid portion. There are companies like EveryNet or Senet, Netmore, Helium, Actility. There are companies that are out there that offer public, but to Carrie's point, the United States geography just doesn't lend itself very well to a dense distribution of LoRaWAN networks. Part of the reason is Carrie mentioned the 10-mile range. I'd say a typical number we would see with our edge devices would be like a 1 to 3 mile range. It is very dependent on geography. It's also very dependent on how much data you're trying to uplink at any given time. And that's just how the chirp spread spectrum nature of LoRaWAN works. And so there are various spreading factors and such that we won't get into here, but it is dependent on how much data that you're actually uplinking. One final just note about terrain. We like to generally refer to terrain as being RF hostile or not. And so just like with your Wi-Fi router, you would want your LoRa gateway to be as high up as possible so that it can see as many edge nodes as possible. You'd want to use the antenna that's appropriate for the application. A lot of people love omnidirectional antennas, but now you're spreading out RF power in all directions. So imagine that you have an application in Colorado Springs where the foothills are on the west, and you have plains on the east. What you'd love to do is stand up an antenna that just directs all of its RF energy east. And so now you'll get better performance. So range is a tough question. I think 10 miles would be stretching kind of our maximum of what we do. I would say 1 to 3 is very typical, and it depends on the RF hostility of the environment. We have set up LoRaWAN gateways in like industrial, for instance, and the 900 megahertz ISM band is very robust in an industrial environment. So machinery, people, concrete, it tends to do really well there. But if you stand up like 2.4 gigahertz Wi-Fi or BLE or even cellular, which can range from 700 megahertz up to about 2600 megahertz, we really see a lot of attenuation. So it does depend on the RF hostility and the RF nature of the environment that you're in. But I think 1 to 3 miles is a good general rule of thumb for something like a LoRaWAN gateway.
Excellent. Now, in that answer, Bob, you mentioned data rate. And so one of the questions here from our audience is asking, what is the maximum data throughput for the single spot? And is it what RS-232 allows?
Yeah, that's a great question. So the RS-232 data flowing from the weather station is roughly 350 to 380-ish bytes, depending on how much is in the packet. So you can imagine if your wind speed goes from 0 to, heaven forbid, 100 miles per hour, you're going to get more data. And so it does vary a little bit. On average, it's about 380 bytes. If you're familiar with LoRa, you know that the lowest spreading factor, maximum amount of bytes you can transfer, is roughly 242 bytes. So now we're caught in this problem of what do I do? The KST module is familiar with spreading factor 7, and it has a limit. And if it sees that it gets more than 242 bytes, it chunks that data up, and then it uplinks just the minimum amount of data set. So there is a header and a data packet. The header has things on it like firmware version, serial number, things that are relatively static. And then there's things like wind speed that are very dynamic. And so what we tend to do is send the header much less frequently and then send the data much more frequently. That allows us to lower that roughly 380 bytes of data into something that fits within a single LoRa uplink. And then we separate out that header and data, If we see a new serial number, we're going to push that to you right away if you plugged in another weather station. So those are some of the dynamics that the KST module takes care of by itself. Dale, did that answer your question, or Carrie, do you want to add anything to that?
Yeah, no, I think you covered it brilliantly again.
Yeah, so let's move on, because I think a lot of the people here are living in places where maybe these public networks aren't available, so they don't have that coverage. So what are the practical considerations for setting up their own private LoRa networks to support a weather station? And how hard is this? Do they need a lot of technical knowledge? How would they get started?
I think one of the biggest benefits that we have in this partnership with KS Technologies, and we may have already touched on this as well earlier in the presentation, but with these devices that KS Technologies is helping us in with the RS-232 communication setup with the weather sensor, is we're putting together a system that's going to be much easier to set up, with having the small components that are needed for it. Something that we wanted to have, something that was going to be as close to plug and play as we could get it. So with this, there's not any SD card that's necessary for it. There's not all these other different components that you need to add for signal boosting, but what we have with our weather sensor, our LoRa communication add-on, that's going to be something that we feel is ideally very simple for setup. Of course, there comes to the mounting and where the sensor is going, but our goal with this kind of device is to have something that's going to be ready to go. Something that was going to be low maintenance, low hassle, and hopefully it's something that we've really achieved. Bob, if you want to add anything to that one.
Yeah, I'll build on that a little bit. You touched on the weather sensor and the KST module side perfectly, Carrie. I don't think I have anything to add to that. But the gateway is where people might be saying, where do I buy a gateway? And let's say I have no coverage and I got to set this thing up myself. What is it like? And so the analogies I like to use, Dale, really two analogies I like to use. Most people have familiarity setting up a Wi-Fi hotspot at their house. Mm-hmm. You buy a router, you go home, you plug it in, you configure it, and you now have Wi-Fi. And then you have to grab your phone and you have to connect it to that Wi-Fi hotspot, and you're entering a password. On a scale of 1 to 10, where 10 is the easiest, let's benchmark that as a 10. There's probably people that are in the crowd who have said, yeah, but I've also done like Amazon, like Alexa devices, or I've done Matter devices, or Apple Home devices. These are devices that normally have a QR code that you scan. It normally involves BLE to your phone. Your phone gives Wi-Fi credentials to your IoT thing. Your IoT thing now connects to the Wi-Fi, and you're off to the races. If Wi-Fi hotspot is a 10, I would say, and this is going to go down if it gets more difficult, I would say the Matter ecosystem type devices, they're probably a 7. They're fairly straightforward. There's an app that guides you through the process. If you're setting up a gateway for the very first time yourself, and it's LoRaWAN, I would give it about a 6. So it's a little bit harder, but it's not impossible. I would say it's very analogous to a Wi-Fi type of setup, or a Matter Home Kit Alexa type of setup. There is a QR code on the back of the KST devices. That QR code is compliant with a LoRa Alliance specification. So if you scan it, everything in that QR code is what's needed in order to commission it to your provisioning server, whether that's running on a local LNS gateway or whether that's a cloud-based LNS. So very similar to the Matter Home Alexa process, we give you a QR code to onboard that to your gateway. And I would say setting up a gateway, a LoRa gateway, it would be comparable to a Wi-Fi type router if folks have experience with that. So not impossible. I think there are some nuances that Carrie went into which are important to think about. Where do you put your antenna? How high can you get it? How do you mount it? Where do you put the power source? And that's where Omron and KST are talking about a kit, where all that is optimized for you, and you get everything from weather sensor to dashboard and everything in the middle, pre-commissioned, pre-built, known, tested, and working. So you have a known good weather station, so you can just get off to the races and start getting weather data. But I think that hopefully gives some more commentary about how challenging is it to set up a LoRa gateway versus like a Wi-Fi hotspot. So hopefully that helps.
That's really helpful. Next question is, we're kind of looking at, okay, you've got it connected and everything, but how well does LoRa integrate with the modern data platforms, the cloud services? You're sensing all this data, but you got to use it for climate, precision agriculture analysis. are there any bottlenecks there of using that data when it gets put up to the cloud?
In terms of that integration, I don't see there being any bottlenecks to that. I don't see there being too much concern for the user to actually use the data once it actually come in. So the great thing about LoRa and its advancements that is coming through is as it has been building, and as we as a society have been building on all of this communication technology, a lot of that new sort of technology and new communication is being built with that integration already sort of in mind. So we have seen as these public networks are getting built up and these private networks are getting built up, people already have that in mind of how is this going to be able to use with already our existing solutions and our existing data gathering setups. So there isn't too much of a bottleneck in terms of that integration. It really, a lot of the difficulty really comes into the actual, the setup, especially in areas where there isn't a whole lot of LoRa already in place. But in terms of like integrating the data itself, I don't foresee too many bottlenecks in that regard. Bob, I don't know if you've seen anything different.
Yeah, I'll add a little bit to that. It has gotten very easy compared to what it was 5 or 6 years ago. So I'll give you two scenarios. Let's say that you stand up your own LoRaWAN gateway and you put the LoRaWAN network server on the gateway. So you're not going to a cloud-based LNS. Most of those gateways, so Multitech, for instance, makes one of these. Rack Wireless makes these types of devices. Most of those devices will give you MQTT, which is a very common IoT transport mechanism. And then it's up to the user to figure out where to receive that MQTT and how to display it. But there are MQTT subscriber type platforms like Hive, AWS has one. And then there are various dashboards you can bolt on top of MQTT out of the box, no programming experience necessary. So at the very least, you're likely going to get MQTT. Some of the public LoRaWAN network servers give you a webhook, which is just a fancy way of saying a dedicated URL. So you put that webhook into your cloud dashboard. Now your cloud dashboard gets that data, and again, you're off to the races. So MQTT and webhook are probably the least refined, but they've been out there for many years, and there's lots of platform level solutions that can get you running. Some of them, though, are a lot more full featured, like the Things Industries. I'll mention that one for a brief second. They have data integration with DataCake, which is a web platform, Tagio, which is very popular. And they do have raw MQTT, so you could pipe it to Lassant as an example, which has a raw MQTT ingestion point. They even offer AWS IoT Core right out of the box. So when the data gets to the TTI LoRaWAN network server, you can literally click an integration button, click AWS IoT Core, give it your credentials, and suddenly you have data flowing through AWS IoT Core. That is not what it was like 5+ years ago, but now it's pretty refined, and there's a lot of great MQTT solutions out there for viewing the data. So I think people have a lot of options now, Dale, from an integration standpoint. Like Carrie mentioned, we find that most of our customers already have something. They're either already AWS customers, or they already use Grafana, or they already have something, and they just want to get that data ingested into their platform. I think that's the beauty of the solution we're offering here. We can give you raw data, and we can get it to your LNS, and you can take it from there, or we can help you integrate it with your business system. So I think there's a lot of great options these days for integrations. Good question.
All right. Well, one quick question to close things out here is, when and where can someone purchase the Omron weather station and the KST5421 module?
Well, it's very exciting. We're getting ready to get to that final release of the weather sensor at the end of the month. But the weather sensor can be purchased directly from Omron. We have sales representatives all over the country that you are welcome to speak to and get a little bit more information on. So the weather sensor itself is being sold directly from Omron itself. And with KST, we do have, since with their development of the communication, we have some sales channel with them as well. We have an exciting sort of package. Bob, if you want to talk a little bit about that.
Yeah, for sure. So you can get the Omron weather station from Omron. From KST, once we finish FCC IC certification, so we're in that process right now, as well as LoRa Alliance certification, then it will be publicly available to purchase on our website. The KST5421, it will already be ready to go. It's ready to plug in. We include both a DC power cable as well as the 1 meter cable connecting from the module to the weather station, so that you can out of the box experience, get after it. And that's for definitely the technically savvy that have a power source in mind and they already have an LNS solution. As Carrie alluded to, we are working with Omron to create an all-in-one kit. So that kit would include a weather station, a module, a LoRaWAN gateway. It would have a local LNS on it, so you don't need a subscription service for it. MQTT would already be enabled, and it would automatically push that data to a cloud dashboard, very similar to what you can see today on KST's website. So that's an all-in-one type of solution where nothing else is needed, and you can just get up and running, and then you can then engage with Omron and KST down the road to figure out what a production solution would look like. So we will be at RE Plus in Las Vegas. It's early September with Omron. So if you're in the area, if you happen to be at RE Plus and you want to see the weather station in action, we'll have a KST module there connected to a weather station with a LoRaWAN network server and a gateway and live dashboard data. So we invite everyone to come and see it for yourselves and ask questions.
All right, fantastic. Carrie, Bob, thank you again for your presentation and for a really lively Q&A. Appreciate it.
Awesome. Thanks for leading the discussion, Dale.
Thank you so much for hosting.
Yeah, in just a moment, everyone, you'll be redirected to a quick survey. We'd really appreciate your feedback, and then to Omron's website, where you can view more about the weather station sensors and solutions. And you will be able to watch this session on demand using the same link you used to join this webinar. Thank you, everyone, for participating. We look forward to seeing you in another live session soon.